These are notes for Honors Math 3 on 6.2, which is Parabolas Day 2. And today we'll be working on writing equations of parabolas given the following characteristics. So I've written down at the top the two equations for parabolas depending on which way they're facing to remind you of that. And also the characteristics values. So our vertex is found at HK. The focal length C is given by 1 over 4a. And the focal chord length is given by 4 times C. In order to write the equation for each parabola, we need to know two things, the value of A and H and K, the vertex. So problem number 1 has characteristics y equals -3 and a focus at -5, 1. So it's best if we start with a sketch. So y equals -3, this is our directrix, and -5, 1. This is the focus. So what we know is that our axis of symmetry would be perpendicular to the directrix and run through the focus. That would be this way here. My vertex also lies on the axis of symmetry, and since the distance from my vertex to the focus, or vertex to the directrix, is equal, that C value, it should be right in the center of these two things. So right in the middle of 1 and -3 is -1, and so this should be where my vertex is, right here. If the focus is meant to be inside of it, then this means that my parabola is opening up from here. So for the two things I need, my vertex is at -5, -1. It's opening up, so I do know that I need the y equals x squared parabola, so I'll be using that equation here. And so far I can plug in the vertex, so y is equal to a, x plus 5 squared minus 1. I only need to find the value of a. Since I know where my vertex and focus are, I know my focal length c. So the distance here from focus to vertex is 2 units. So I have that c is equal to 2, and c is equal to 1 over 4a. So 8a equals 1, and a is 1/8. And we'll double check, because my parabola is opening up, a should be positive. So we're going to plug this value in here. And that's the equation for our parabola. Number 2 gives you the coordinate pairs for focal chord endpoints and tells you that A will be negative. So we'll start with a sketch here. So I have a focus point at 15, 2, and another focus point at -1, 2. These are endpoints of the focal chord, so they are actually coordinate pairs that exist on my parabola. What I know is that right in the middle of them should be the focus. That should be the focus. Because this is my focal chord, it runs parallel to the directrix, and so also my axis of symmetry should be running perpendicular through here. So my vertex is somewhere on here. Because A is negative, this tells me that my parabola is opening down. So we're just not sure where that vertex is. And we do need to find that value here. So we're going to start with the focal chord length for C. So the length of the focal chord from -1 to 15 is 16. So this tells me that C is 4. That helps because the distance from the focus back to the vertex is always C. So we did use that last time. So right here, this distance is 4. So I do need to find the x value here in the middle of -1 and 15. And my y value, right now we're at a height of 2. So if we move up 4, we end up at a height of 6. So my vertex has a y value of 6. So I just need to find the middle of -1 and 15. To find the middle of any two numbers, all you need to do is average them. So on this side, or in your head, you might average these to come out to 7. So that's the location here. And that is our x value for the vertex. So 7, 6. So I can start building my equation again, which is going to look similar to last time. Y is equal to a x minus 7 squared plus 6. I just need to find the value of a. So there's some different ways you can do this. One thing I can do, since I already know c, I can use that formula since c and a are related in the focal length formula. So I can take 4 and set it equal to 1 over 4a. And I can solve this way. So this gives me 16a equals 1, and a is 1/16. Although it is negative, right, since the parabola is facing down, and we were told that a is negative, so it should be a negative 1/16. Something else you can do here is, because you were given coordinate pairs that exist on your parabola, you could plug in one of these coordinate pairs for the values of x and y along with your vertex, and you can use that to solve for the a value. So we're actually going to use that in the next problem. We're given a vertex at 4, -5, a horizontal axis of symmetry, and the parabola contains the point -8, 3. So here we have already our vertex. And so really we're just trying to figure out what the a value is. And then is this an x equals or a y equals x squared parabola? So if I have a horizontal axis of symmetry, this is my axis of symmetry, and we also contain the point -8, -3. Out here. So if this is my vertex and we want to connect to this point, this seems to make sense that it's opening here to the left. And so I'm looking for x equals a, y minus k squared plus h. So right now, if I want to plug in the vertex, x is equal to a, y minus -5 is plus 5 squared, and then plus 4. To solve for a, what I can do is use my coordinate pair here. This is going to be an x, y. We'll plug in those values and solve. So -8 is equal to a times -3 plus 5 squared plus 4. So in solving, we'll subtract 4 from -8 and simplify here. 2 squared is 4. And then divide -12 by 4 to get -3. And that makes sense. It is opening to the left, so my a value should be negative. We'll just plug that back in here and have our equation. All right, the last problem is going to ask you to sketch the inequality. So this is just a parabola. We're sketching x equals y plus 1 squared minus 2. You'll remember when it comes to inequalities, though, a few things. So first, because there's no equal to sign underneath it, we're going to be sketching a dotted parabola. And then we'll also be looking for shading somewhere around it. All right, so we'll start here with our vertex. So HK, H is -2, K is inside with Y, -1. So -2, -1. Since it's an x equals, it should open right or left. And since y squared is positive, we are opening to the right from here. So we could plug in some numbers if we wanted and find some values. For instance, if y is 0, we get 1 squared is 1 minus 2 is -1. So -1, 0. And using symmetry, I'll get -1, -2 as well. All right, so there is our dotted parabola, and now we're going to look for the shading. So we're looking for a number. You can use any number, any coordinate pair here to test. So if we choose a coordinate pair that's inside the parabola and it works, we would shade inside. If it doesn't work, we'll shade outside. Or we can pick a point that's outside. If it's a solution, we'll shade outside. If that point is not a solution, then we'll shade inside. So I'm actually going to pick, I think, a point on the inside. So let's just go with something here like 1, 0. So if I plug in the point 1, 0, we're plugging in 1 for x, 0 for y. So that would give me 1 is less than 0 plus 1 squared is 1. Minus 2, so I have 1 is less than -1. So this is not true. All right. Which means that this point is not a solution, so I don't want to shade inside. We want to shade around the parabola. Make sure you fill up your graph here with your shading. So you'll see a few of those problems throughout the unit as well. And that is the end of our notes for 6.2.